So the remaining astronomical concept is the velocity fluctuation in the sun's motion, or equivalently, it should be the Earth's motion, because when we talk about the velocity fluctuation in the sun's motion, it was based on our observation from the Earth. So in the picture, okay, this is a modern concept showing how the Earth is orbiting around the sun. So it has also labeled dates of the solstice and the equinox. So the first question is, how many days are there between the winter solstice and the spring equinox? So we see that it should be 89 days. But if we look at the days between the summer solstice and the autumn equinox, there should be 94 days. So that means the Earth is spending longer time in the later part of the whole tropical year. So that's an interesting observation. So what contributed to that? It was exactly because of the velocity fluctuation. So let's look at this picture. So if the whole Earth is orbiting around the sun at a perfect circle, there should not be any velocity fluctuation. And according to our knowledge in physics, if the Earth's orbit is not a perfectly circle but a slightly little ellipse, then the speed or the velocity of the orbiting object should be changing. As we can see, when the Earth is orbiting closer to the sun, according to the law of physics, it will be moving faster. But when it is further away from the sun, it will be moving slower. So now we can see that as a result of the non-circular orbit, in addition to the law of physics, we know that here comes the velocity fluctuation when the Earth is orbiting around the sun. How much the ancient Chinese people know about that? So as recorded in AD 618 in the Da Yan calendar in Tang Dynasty, they found that the sun's apparent velocity was the highest in the fortnights approaching the winter solstice. So in the AD 1281, Guo Shouzheng affirmed that the winter solstice was the time when the sun traveled at the highest speed. Although there wasn't any record saying that how much it has been slow or faster than normal, but at least they detected something like the velocity fluctuation. And on the other hand, you may ask, do they have any other theory to explain this kind of velocity fluctuation? So the answer looks to be negative. At least we know that calendar making must require continuous and accurate observation and recording. So we do hope that we can find some ancient record, maybe full or partial sets of record showing the raw data of the observation. We have mostly the resulting calendar, but for the raw data, we miss almost all of them. That's another question.